This video is solving systems of equations with matrices. You can represent a system of equations in a matrix. It's literally an array, a rectangular array that represents a system of equations, where the rows are the number of equations that we have, and the columns are the number of variables that we have. So the columns are vertical and the rows are horizontal. Any number that's represented in the array is called an element. And if you notice, these subscripts give location in a matrix. So A11 is the first coefficient in the first row and the first column. A22 is the second coefficient in the second row in the second column. Normally, we'll use this information, the actual definition, to do operations with matrices. So I'm going to show you how to set up a matrix using a system of equations. So here I have three variables, x, y, and z. So I have three different equations so that I could solve for them. You can set this up as the matrix A times the matrix X equals the matrix B. So I'm going to do that really quickly for you. I'm going to take the coefficients off of the variables. 1, 3, 2, 2, negative 1, 3, and 3, negative 3, 1. And then the X matrix would be X1, X2, X3, or X, Y, and Z in our case. So if we multiply those two matrices, we get our coefficient matrix here. 1 and 4, there we go. That would be our matrix B. Now, we're not going to use this matrix setup to solve equations today. We're going to use what's called the augmented matrices. So I can't spell. There we go, augmented matrix. So to do that, we put both the coefficients and the constants from the answer together. So I'm just recopying my original matrix here. 2, 3, 1, and then past the line you would put the numbers after the equal sign, the constants, 3, negative 1, and 4. So just look again, I took all the coefficients off and I kept their sign when I did that. So this is how you set up an augmented matrix. Let's give it another try. Let's say that I had 3x plus 2y equals 5. X minus y plus 3z equals 1. And 2x plus y plus z equals 4. So to write the augmented matrix for this one, we are going to do a 3 by 4 matrix, including our augmented row here, but the missing coefficient, the missing variable in this equation is going to be 0. So because it doesn't have a z, there's going to be a 0 in the z's position. I did this one a little bit crazy. I went all out of order here. Sorry about that. I'm just going to take the coefficients and the constants from the equations and put them in a matrices. Okay, and that's all you have to do. So a couple of times on your homework and on your exam, I ask you for the augmented matrix. That's the answer. Then you stop. Now, I will also ask you about doing some elementary row operations. That's because I can take each one of these equations and I can multiply it by a number. I can divide it. I can add it to another row. I can rearrange two rows. All the definitions for those are on your definitions and theorems page. They're called elementary row operations. Again, that is interchanging, multiplying, and subtracting and adding. We're going to do some of those, but the goal and the reason behind those is to get our equation or our matrix in what's called row echelon form. So this is Gaussian elimination. There was a famous mathematician, Carl Gauss, who came up with this method of using elementary row operations to reduce a matrix so that we could backward substitute. So what we're looking for in our matrix is for some sort of setup here, and I'm going to show you what it looks like in just a second. Sorry. Okay. So how can you tell that you are in row echelon form? Well, the diagonal here are all ones, and everything below the diagonal is 0. Because these diagonals represent our equations, the top corner, A11, is x, the middle is y, and the bottom down here is our z value. So once we have a value for z, here this would be z equals 1, we could start to backward substitute by rewriting our equations here. If you see what I'm doing, we could substitute z into this and we could find an answer for y, or I could substitute z and y into the top equation. Hang on, trying to talk and write is difficult. There we go. So I could backward substitute just like we were doing with elimination before and substitution before, and I could get an answer for x, y, and z as long as it's in row echelon form. Again, that's Gaussian elimination. This other fellow came along, Jordan, and he built up on Gauss's theorem, and he said, what if we do reduced row echelon form, where we take our matrix all the way back to what's called the identity matrix, where not only are the diagonals set up beautifully, but the whole matrix is, and if you take a look right here, you'll see. And then we would just have our answers here. So we could see that z equals 1, y is 9, and x is 6. So you could use either one of these to solve, oops, sorry, gosh, Jordan, to solve matrices, to solve systems of equations, to find our missing variables. Okay, so we're just going to jump right into it. We're going to focus on just Gaussian elimination and get these diagonals to 1s, and then we'll backward substitute. So I'm going to do 2 examples. They do take a minute, so you just need to be patient, and you're looking for patterns. You'll see what I mean. So I'm going to set up this first one. Just give me a second. Before we get started on our example, I wanted to show you what some of the operations might look like. The notation looks a little weird. So this doubled arrowed arrow means interchange. I can interchange any 2 rows. So this says row 1 switch with row 2 replace. Oh, I wouldn't have a replace. I apologize. So row 1 switch with row 2. And this one would be row 1 plus row 2 replace row 2. And this says 2 times row 1 minus row 3 and then replace row 3. So we're going to do some more work with that. I just wanted you to see it before I started here. I'm going to change my system of 3 equations to an augmented matrix by taking off the coefficients. Here we go. 3, 1, 4, negative 1, 3, 2, negative 1. Okay. Now, we are looking for this 2 right here to be a 1. You can do 2 things that I can see right at this first minute, and there's not only one pathway, by the way. Just find some patterns, manipulate the problem to get what you want. So again, this is row 1, this is row 2, this is row 3. I noticed that all of row 1 are factors of 2. So I could do 1/2 of row 1 and then rewrite row 1, and I'll have what I want. So half of row 1 here is 1, 2, 2, 2. So I just did everything divided by 2 in row 1. And then nothing else changed. So I'm going to copy the rest of the matrices just like it was. Okay, the matrix. Now, I have a 1 there. That's what I wanted. Perfect. I want this 1, that's an A1, A2 1 right here, row 2. I want it to be a 0 because I want it to look like row echelon form. So, there's multiple things you can do. So I could add it to row 3, and because 1 minus 1 is 0, right? But I can see right here that I want this one to be a 1 also. So if I do row 2 minus row 1, I'll set it up so you can see what I'm talking about. Row 2 is 1, 3, 1, 4, and row 1 is 1, 2, 2, 2. If I subtract these two, I get 0 here, and that's what I was looking for. But I also get a 1 in the second position, and that's what I need also. So I'm going to keep going with this method. 1 minus 2 is -1. Be careful here. People will mess up with their signs, and then they'll get confused and have to restart the whole problem. So just be careful as you're doing your signs. Okay, now, another common mistake here is people will think, oh, we changed row 1 and row 2. We only are going to change row 2. So I'm going to replace row 2 with a new row, but everything else is the same. Even though I used row 1 to add, it didn't change it. Just manipulating a little bit. Okay, I have 1 and 1 and a 0. I'm getting close. I want this one to be a 1 and then these two to be a 0. So what do we do here? We can use this row and this row. They're both 1s. When I add them together, they give me 0s. So I'm thinking row 3 plus row 1 and replace row 3. Now I am doing some side work. You don't necessarily have to do this side work if you don't need it. It's just for your benefit so you can see what work I'm processing. Row 3 is -1, 3, 2, -1, and row 1 is 1, 2, 2, 2. I'm going to add. And this is only replacing row 3, so I'm going to go ahead and replace row 1 and 2 in my matrix with their original numbers so I don't forget. Okay, 0. That's not a 1, but we can fix it. 4 and 1. Now, if you found a different pathway to get that immediately to be a 0 and a 1, great. But took the long way here. Okay. Now what do we want to do? I need this 5 to be a 0. Okay. Well, row 2. Let's see. Row 2 is a 1. And if I want to do 5 minus 5, I can do row 3 minus 5 times row 2 and replace row 3. So that means I'm going to copy this matrix down so I don't mess up. 1, 2, 2, 2, 0, 1, -1, 2. Neither one of these rows are actually changing. So I'm going to copy them down. On the side, I'm going to do some work and copy the old row 3, which is 0, 5, 4, 1. And then I'm going to write down 5 times row 1. So 5, -5, and 10. Okay, now if I subtract those, 4 minus a -5 is 9, and then 1 minus 10 is -9. So my new row 3, oh, that's perfect. We're getting really close. If I multiply row 3 by 1/9, I'll write that for you. 1/9 times row 3, replace row 3. That gives me reduced row echelon form. So 0, 0, 1. That's what I'm looking for. Okay, and I'm kind of running out of space, but we're going to do this real fast. Just a sec. Okay, I'm running out of space. So I know right now I'm going to use my matrix to rewrite a system of equations. So 1, 2, 2, and 2 is really x plus 2y plus 2z equals 2. And then y minus z equals 2. And then z equals -1. So this is our purpose here. We're getting close. I have found z. Now that I found z, I can backward substitute. And then I could say that y minus -1 is 2. So y plus 1 is 2. That means y equals 1. Now that I know z and y, I can plug them both up here into equation 1. And that tells me that x plus 2 times 1 plus 2 times the negative 1 is equal to 2. And then these are going to cancel each other out, but let me show you. 2 minus 2 is 0. That means x is 2. And we did it. We got there. We got that x is 2, y is 1, and z is, oh darn, negative 1. Here, I got this. I can make it work. Okay, you write your answer in x, y, z. So 2, 1, negative 1. Okay, if you got it, you can go and try your homework problems. But if you need another example, I will show you one. Just 1 second. Okay, I have an idea. Let's take the example that we wrote in an augmented matrix earlier. I believe it was 3, 1, 2, 2, negative 1, 1, 0, 3, 1, 5, 1, 4. Okay, we set this matrix up earlier. So we're going to use row operations and try to get this in reduced row echelon form. Or just row echelon form, actually. Let's just get in row echelon form, which means I need all my 1s to be on the diagonal, and then these numbers need to be 0s. So again, you're just looking for patterns. I need this spot to be a 1. So I know, looking at this column right here, that I have a 1 and a 2. So I can multiply this by 2 and subtract and get row 1. But it's easier for me to combine row 1 and row 3 because 3 minus 2 is 1. So I'm going to do row 1 minus row 3 and replace row 1. I guess I could just switch these and have what I want, but I already wrote it down, so let's do it. So we have row 1, which is 3, 2, 0, 5, and we're going to subtract 2, 1, 1, 4. That gives me 1, 1, negative 1, and 1. So my new matrix is 1, 1, negative 1, 1 on the top. That's my new row 1, and that's the only thing that I've changed. So the rest I'm going to copy down. Okay. Now, what to do? Oh, I want this row right here, this 1, to be a 0. So, So what I'm thinking here is this row minus this row. Row 2 minus row 1, and then replace row 2. I'm going to go ahead and copy the rest of the matrix down because I'm only changing row 2. So I need this 1, 1, negative 1, 1 thing to happen at the top. And then the bottom row is still 2, 1, 1, 4. So I'm just going to replace the middle one by adding or subtracting here row 2, which was, and then row 1, 1, 1, negative 1, 1. Just be careful here because we're subtracting. Negative 1 minus 1 is negative 2. 3 minus a negative 1 is 4. And 1 minus 1 is 0. So my new row is 0, negative 2, 4, and 0. Okay, we're getting there. I need this negative 2 to be a 1. So I'm just going to divide by negative 2. Technically, I'm going to multiply times a fraction of 1/2 times row 2, replace row 2. I'm just going to do that math. I hope that's okay. 1, 1, negative 1, 1. That stays the same. This one stays the same. The only thing that's changing again is row 2, okay? Oh, divided by negative 2, which gives me 0, 1, negative 1, and 0 divided by anything is 0. So we have our diagonal. I might actually change this a little bit, but I'll get it back to where I want it. That's okay. But we do need to fix this 2 right here in the corner in A31. This 2 needs to be a 0. The only thing that I can see is multiplying row 1 by 2, adding it to this 2, or subtracting it to that 2 and getting a 0. So we're going to do row 3 minus 2 times row 1 and replace row 3. So that is 2, 1, 1, 4 minus, and as I write down row 1, I'm going to multiply it. So 2, 2, negative 2, 2. There's my 0. 1 minus 2 is negative 1. 1 minus a negative 2 is 3. And 4 minus 2 is 2. So our new row, only thing that's changing this time is row 3. So here's row 3. We just found it. Row 1 and 2 stay the same. Okay. We're getting there. We need this negative 1 to be a 0. I mean, I'm just going to add it to either one of these rows. Actually, I have to add it to this row because if I add it to this top row, 1 plus 0 will change that to a 1. So you have to be careful. I'm going to add it to this row that's already a 0 because that's not going to change. But that is going to become 0. So I'm going to do row 3 plus row 2 and replace row 3. So again, even though I'm adding it, row 2 is not changing. So I'm going to copy row 1 and row 2 down just so I remember that. Only changing row 3. Okay, so I'm just going to stack them up. We have 0, 1, negative 1, 0, 0, negative 1, 3, and 2. Here we go. Looks perfect. That's what I'm looking for. Okay, we're so close. I can see it. Can you see it? Okay, so we want this 2 to be a 1, and they're both 2's. It's not going to make a fraction, so I'm just going to do row 3, and I'm going to do half of row 3 and replace row 3. So that gives me 1, 0, 0, 0, 1, 1, negative 1, negative 1, 1. Sorry, I read that all out of order if you were writing that with me. So my bottom row is 0, 0, 1, 1. That's the only thing that changed. I copied down the rest. Now this gives us our answer. And I ran out of space again, so I'm going to pull another page here. I'm going to write my answer down in equation form really fast. So x plus y minus z equals 1. Y minus z equals 0, and z equals 1. So backwards substituting, y minus 1 equals 0, so y equals 1. And then x plus 1 minus 1 equals 1. So x equals 1. So I have 1, 1, 1. Oh, wow. Okay, good luck. Please reach out if you need help. You can do it.